Welcome to another day on the Journey to Chem. Please do the 2 warm-up questions to the best of your ability. They're review for the semester exam. I know you can do these, and we'll see you in a moment. In number 1, I am changing formula units to mass. And formula units are the tiniest of little particles. And so it takes a very large number to get anything measurable. And notice that I have a formula here, potassium sulfate, and you were given the words. And you must always change words to formulas. So we're constantly practicing naming compounds. Now I know that there is in 1 mole of potassium sulfate, there are 6.02 times 10 to the 23rd formula units of potassium sulfate. That gets me to mole central. And then I go to mass. And in order to get the mass, I need the gram formula mass. And there are 2 potassiums and 2 times 39.1. And sulfur is 32.1. And 4 oxygens is 4 times 16.0. Now remember, many mistakes are made in adding up the AMUs. Therefore, I write them again. 78.2, 32.1, and 64.0. And when I add them up, I get 174.3 grams per mole. And because I'm looking for mass, it goes in the top. 174.3 grams of potassium sulfate is 1 mole of potassium sulfate. Then I do the math. And I take my original number divided by 6.02 exponent 23, not times 10 to the 23rd. That is very important. And I must tell my calculator the order of operation. And then I multiply by 174.3. Any number that's in the top, I multiply. Numbers in the bottom, I divide. And when I do the math, I get 1.0365 times 10 to the negative 3. I look back at my original number, and my original number had 3 significant digits. Therefore, I need 3 significant digits. And I look at the 6, and it rounds the 3 up. And my final answer is 1.04 times 10 to the negative 3rd grams of potassium sulfate. And that's the answer to number 1. Number 2 shows that we must be able to complete and balance equations. And the first one in number 2, A, is to decompose an oxy acid. And therefore I have to review my penguin sheet. I must know those acids. Well, phosphoric acid is H3PO4. And whenever I decompose an oxy acid, I always get water and some form of the acid anhydride. Now, to know which acid anhydride I'm going to get, it will be consistent with the charge on this phosphorus. And phosphate, the polyatomic ion, has a negative 3 charge, which is why we have 3 hydrogens, because compounds must be 0. I set the equation equal to negative 3, the overall charge of this polyatomic ion. Oxygen is negative 2 times 4 gives me negative 8. And therefore, in this case, phosphorus is plus 5. If it's plus 5 here, it must be plus 5 here. And oxygen, when it's in its periodic position, will be negative 2. Compounds must be 0. The common multiple is 10, P2O5, because plus 10 and minus 10 is equal to 0. Now in B, we are decomposing calcium hydroxide. And calcium hydroxide is a base. And whenever I decompose a base, I also always get water and a base anhydride. Now, it's not as difficult in this case. I must still balance the formula. However, calcium is plus 2 here, and that is not as difficult to determine as this phosphorus was in the acid. And then this is balanced. Now, C is one of my all-time most favorite. I just love this one. So 2C is lithium chlorate. Lithium chlorate. And whenever I decompose the metallic chlorate, I'm driving off the oxygen. And we actually did a lab that was doing this exact same thing. So I get my oxygen, and when I take the oxygen away, I'm left with a metal chloride. Now, once I get my compounds, then I must balance the number of atoms. And there are 3 oxygens here and 2 oxygens here, and the common multiple is 6. Therefore, I need 3 oxygens and 2 lithium chlorates, which gives me the 2 lithiums, and therefore I must put a 2 in front of the other lithium. I like this one because of this 2-2-3 ratio. It's very, very nice. Now the next one is chlorine plus sodium iodide. Now I must remember my diatomic molecules. Iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. I brought clay for our new house. And that's a very good way of remembering those. Now I see that this is an element because diatomic molecules are considered elements, plus a compound, and therefore the negative will displace the negative. Normally chlorine is at the negative position. And therefore I get sodium chloride and iodine. I tend to put a little hooky on my carbon, so sometimes, or chlorine, my C's, and so sometimes I have to erase that little bit. Now I have 2 chlorines here and only 1 here, so I need a coefficient. Once I have written my formulas, I cannot go in and change those little subscripts. I can only change the coefficient, and then I have a balanced equation. Now finally, we have silver plus lead 2 nitrate. And the lead Roman numeral 2 is telling me that lead has a +2 charge and nitrate is -1. And therefore I need 2 nitrates to get my compound to 0. Now this is another type of a single displacement because I have an element plus a compound. Now silver is a metal and it will displace the metal or the positive position, and sometimes that's hydrogen. But in this case it is a metal, and therefore I get lead plus silver nitrate. Now I have 2 nitrates here, therefore I must put a coefficient here and a coefficient here, and then that one is balanced. Now the worksheet that you did last night is very similar to half of what you will see on the semester exam. And tonight you have another practice sheet of 7 problems for 50% of the exam. So I suggest that you try to do those problems without looking at your answers or your warm-ups to try to help you. And then once you figure out that you need some help, then go ahead and look. But that gives you a good idea of what to expect for the exam. But we'll go over some more about the exam tomorrow. Well, that was some fun, and I hope you're reviewing those warm-ups because that's the best way to study for the semester exam. And I can't wait to see you tomorrow. Bye!